So this is, if it's going to work, yes, this is all about sort of lessons for the future of data describing buildings and their performance. It's quite a broad subject area, and I've been quite vague in the title, but it's mainly related to BIM as the new data paradigm in inverted commas. And it's a really old data paradigm, rebranded and made more accessible and widely used by everybody now. And it's probably a bit old to talk about BIM as a new thing as well. So it's mainly around that, but sort of loosely related to all the other sort of bits feeding into this, feeding into sort of building data and that general area. So general structure of this webinar, I'll give a bit of background and context. So what my previous experiences are some research that I've done and the findings of that, and an example from a project I worked most on. Give a bit of an overview of the current situation in the construction industry, mostly related to the UK, but it's very representative of all countries at similar levels of BIM adoption, new technology adoptions, things like that. And most countries have their own standards for information that are fairly comparable to each other. What I mean by building performance, where everything is quantifiable, and what is performance essentially, and how do you quantify it, and the challenges in handling that kind of information, how projects are structured in relation to data, and what impact structuring is having on the creation and use of data, and the skills and tools that are being used and people have to interact with that kind of data, and how they're kind of moving forward currently, and what challenges there are in that. And then finally that exemplar project, where you can kind of see what would happen if, that's my what if thing, my main bit of research, what if data was accessible and available and we could actually use it in some kind of way. So perspective wise, I did a sponsored NGD with Bureau Happel Engineering, as you can tell from the branding of this webinar, looking at how BIM could be used to manage building energy performance. And that was split into a few different objectives. First of all, exploring the area. So that was looking at organizational readiness for BIM, how mature they were in terms of technology adoption and skills and use of tools and processes. And then how BIM was being used to store performance-related information specifically, but again, related to all information generally, because the way you store information tends to be about the same, with slight variance based on what kind of information it is. And from that, developed a proof of concept linking sort of design model to monitor performance, not really for application, but to understand the challenges in how BIM could be used in this way. And then from that, evaluating the process. So that's what I've kind of done in the past, and that's my perspective. Now, it's not big data. Big data in construction is the new buzzword. It's becoming the new BIM in terms of what people want to hear in big corporate presentations. But performance data is big enough to warrant some thought about its management and how it can be used to influence decisions or decision making. So it's biggish data, but it's not big data in the true sense of the word. Big data is massive. This is biggish. So on to the subject at hand. There are loads of standards for information. I mean, again, still looking at BIM as an example, how information is structured or standardized in some way. And BIM is just a data standard. It's not a very standard data standard. It changes based on where you are and how you interpret whatever set of rules apply to you as a member of the construction industry. And on the screen there you can see a few of the ones in the UK that are current. And yeah, I think they're all current. There's no future ones there. And they relate to different aspects of information in construction. So how people collaborate, the codes of practice for that, how you manage information during different phases of projects, how you manage asset-specific information. So that kind of goes into the realm of CIB data and sort of asset management strategies, things like that. And now it's getting a bit more niche. Now we've got the general areas for information standardized. We're starting to look at security information and facilities management information, infrastructure information, health and safety information. All of that is data related to specific fields stored in a standard way, or at least you'd hope it'd be stored in a standard way, because as you'll probably see later on, it's open to interpretation. Whoever's using those standards tends to use them in slightly different ways, so they may not actually be standard. So most information is structured in some way. There is some hierarchy to it, and that's how computers know what to do with that information. Geometry is a really good example for this. So inside a BIM environment, or CDE if you prefer the acronym, you'll have some geometry information, usually. It's not the only thing, but it's a good sort of data hierarchy standard thing to look at. And that object has attributes. So this cube is made of vertices, or the cube is made of faces defined by vertices, and it has a name, cube1, and it has a purpose, which is placeholder, because that's what I decided to call it. Fans of Python will recognize this syntax, how it's kind of structured this information. But essentially, on this page, I've created a standard for defining geometric information, which has a hierarchy. So it inherits something from another bit of information. So you define the vertices as points in space, and the faces are defined by 4 vertices, and then the cube is defined by those faces and the vertices, and it has metadata associated with it. There we have some data that is structured and it's hierarchical, and geometry is really good at sort of demonstrating that. Lots of data isn't structured. It's really not. So you tend to have other little standards implemented here, there, and everywhere to kind of help you understand what is actually being shown to you or what you're accessing. Access to information is essential. If it's inaccessible, it can't be used. And knowing where to look or how to get what you need is the first step. So in BIM, at the highest level, that's maybe naming a file containing some information. Naming conventions are really helpful. The one used here, I think, is from one of those British PAS 1192 standards, but they're fairly sort of common throughout the industry. And you can see, you know from that model name or that file name, you know it's an architectural model, and it shows building number 2, which contains floor 0, and that's the name of the project, and it tells you what is actually within it as well. Now, it helps to know what all these mean. So if you were just given a file name, you'd need to look at the standard to understand it. But if it is standard, then that's great. You just look at the standard. But most projects, you tend to have their own little caveats. And at the beginning of that project, it's been specified that a certain naming convention would be used. So it may not be used by everyone at all times in the same way, which is one of those problems that we have to face. And then data itself in models, in building information models, could be in lots of different formats. A building information model isn't a standard format. It is a method of storing information that links to other information, and that links to other information again. And because we're part of the free market, and it's every company's right to charge for their knowledge and tools developed from that knowledge, you tend to get big software houses providing methods of creating that information or interacting with information in that way. So de facto standard Revit being a big one here in architectural engineering modeling. If you are to open up a Revit model from an architect and you're using Revit, then in all likelihood it will open and it will be fine. Open source formats could be more applicable to lots of different areas, but they come with a few little notes that need to be taken care of, in that they may be modeled slightly differently. Or the stakeholders are using them in slightly different ways or for different purposes, so they are structured slightly differently as well. While the information is stored there in a standard way, the workflows that they've developed around their method of using open standards may vary such that the information is stored in a slightly different way to somebody else. So one model read by one person may be different to a model read by another person, even if it's from the same data. Now, I think I'll get onto that later on with how these formats sort of exchange between each other. But the main difference between these proprietary formats and the open source ones is that the open source ones are built for extensibility, so they can be used and changed and modified, whereas the proprietary ones are built for purpose. And that purpose is what industry likes, because everybody is going to that same purpose of a model that is usable and data that is usable. And on the side there, you've got some ad hoc things which are kind of plugins to a few different tools, which mean you can interface with data in strange ways or different ways. But because all of those could essentially be taken to mean, or taken to be different standards, you then tend to end up with this kind of situation where there's lots of different standards everybody uses, and somebody says, well, we don't like having all these standards, we'll create a new universal one that everyone will use, and that just adds to the list of standards. A bit like the omni-class and uni-class thing for classifying different aspects of models or building elements. They're essentially doing the same thing, but they've been adopted by different people in different places, and there's probably going to be some overlap between them, and at some point somebody will develop a new one that incorporates uni and OmniClass at the same time. And you've probably got lots of examples in your own in your own countries and projects that you've worked on as well. So building performance data specifically is what I've kind of researched in the past and what I'm kind of all about now. It's difficult to define in one clear way, but the whole building design guide defines it or describes it in terms of 8 attributes. But these could be sort of further subdivided. So sustainability could be divided into embodied carbon within materials, or energy consumed by an object or building. Or productivity may be a function of occupant comfort. So if your people within the building are not comfortable, they're not going to be productive. So you could subdivide it as you choose. And my work until now has focused on energy consumption and occupant comfort on these kind of metrics. And they can, again, be split between different stages of the design and the use of a building's life cycle. So please just jump in at all if there's any kind of little things you want me to clarify while I'm going through. But otherwise, I'll keep going through and I'll talk at the screen for a little bit more. So building performance during design. Decisions are made which influence the performance of the building at this stage. You determine the impact of those decisions before the building's built, and it's much more cost effective than making any changes after it's built, because then you have to get the contractors in and add bits and pieces and take bits and pieces away. So the majority of early decisions are made using kind of experience judgment rules of thumb, design guide-based specifications. And then later you start doing a bit more in-depth analysis of the things that need in-depth analysis to sort of see what specific system performance levels you need or levels of comfort you could potentially achieve. Now all this is data. Again, it's data. It's always data. This is information describing how a building will perform during design. And all of that information has to be stored somewhere in some way, shape, manner or form. And that's a little bit of a challenge because there is no standard for that currently. And that information there you see, that's from a CFD model, and they generate lots of data, like gigabytes and gigabytes for a regular simulation run depending on the setup. And standards are very important to storing that amount of information. During use of a building, it depends on the building's typology or the availability of data being collected about its performance. But most modern buildings are now being built with some form of automation being considered, from basic sort of thermostats for heating and cooling, or fully automated system operations, sensing demand and supply for light, heat, power, things like that. Even machine learning implemented to sort of look at this data over time and guess what the occupant's going to require the next day and the next day and the next day. So eventually the building will run itself. I doubt that would ever actually be the case, because people are strange and do strange things and decide not to do the same thing every single day. So I think things like the Nest thermostats and home automation are starting to take on this in domestic properties as well. But implementation is really difficult because every house is different, every building is different. And there needs to be some way of hosting all of this data as well. Like in things like the domestic sort of realm, if you have a Nest thermostat, that data is going to be sent away to the cloud somewhere where it's stored on a server, and you can access it, and so can Nest, and so can whoever owns Nest, and they can use it to market new products at you, but you use it to heat your home effectively. So yeah, how information is being transferred between monitoring and some big data aggregator somewhere is one area that might warrant some further investigation some way down the line. And it's assuming all this information is being recorded effectively, or at all, using all the systems available. And that's usually what data ends up looking like if you're collecting a lot on a building. It's not going to be structured. It's just lots of stuff with no real method of accessing what you want to access unless you have an in-depth knowledge of that stuff and work with it every single day. But yeah, during sort of design and use, the standards are only as good as their suitability and how they are implemented. They provide a common thread to follow the story of a project or a building and enable somebody to not fully familiar with it to access it or understand it in some way, or how the information is interrelated or how to interface with it. But definition of some kind of method for standardizing that information is essential. Adhering to a standard is much less difficult if there's some kind of documentation that describes how that standard should be done. A lot of building projects tend to be that they last a long time, and people in those projects can change, stakeholders change. They may be novated, it goes on hold for a little while and then it comes back again, or the people that are designing the building change hands halfway through because the client's not happy with them. All of those are challenges to maintaining that kind of structure. And a common standard across an entire program is fairly rare to find. And that's also compounded by the amount of information now being generated. It used to be that anything you could draw would be added to a stack of drawings of that building, and then eventually that would be given to the client at the end. But now, everything you can draw, well, you can draw 10 times as fast in 7 different ways on a computer when you're sat there in about an hour. And that's a lot of data to generate. You could run several parametric simulations, and you've got gigabytes upon gigabytes of data. You can't give that information to anybody because nobody is going to be able to handle that much information in one big data dump. So there needs to be some kind of standard for data management as well, and transferring them between stakeholders in design and operations process. Again, bandwidth is now a limiting factor. So if you're generating gigabytes worth of data and you're collaborating with somebody that's halfway across the world, how are you going to send them a huge amount of files? I mean, it might be faster to save it all to an SD card or a few SD cards, put them in your pocket, get on a plane and fly over. I think there's a really nice sort of thought that I think if you filled up a bag full of SD cards of data and took or filled up a lorry full of SD cards with data and drove it across the country, that's a lot faster than trying to transfer it over the internet. So that's becoming one of those challenges we need to start to address. And that's if information handover is required at all. We could be dealing with information in a centralized environment. An entire project could be hosted on a server somewhere. And everybody just dials into that server or uses a virtual machine or works remotely. So we don't need to worry about transferring information. It's stored somewhere centrally with multiple redundancies and backups. So it's safe. So lots and lots of challenges to sort of address with building data and data in the construction industry currently. And it's what's happening a lot at the moment because we are moving towards common data environments. That is the challenge at our doorstep. So exchange information, I kind of touched on it just now, but it's an essential part of the design and operations process. And face-to-face is always the most effective way of conveying intent for that data, which might be lost in documentation. And intent tends to get lost quite a lot. Construction stage. There is a question, isn't the project structuring missing the construction stage? It is. There is a stage between sort of the design and before the design and the use of that data. At that stage, a lot of the information tends to go missing. Usually because the designers have their data sets, have their information, they give it to the contractor to make use of and make their final changes and actually implement their designs. But usually the contractors have their own methods of doing things, so all that work tends to be novated or to change slightly. So again, you've recognized another one of the challenges in handling the amount of data and what data we are handling, unless you have the same stakeholder throughout the entire process, which you could assume to be the client or the project manager, but they're not data managers, they're not database administrators. They don't particularly know about the standards of information to which everything needs to adhere to. They manage a project or they want a building. So they may not have the knowledge to be able to specify this is exactly how we want it to be done at every stage, and information must be in that standard. So there is a bit of a disparity between design and operation when you have the whole construction process and changes are made to the building in that stage as well. So yeah, that is another one of those challenges. But back to information exchange. The standards that we are using for exchange as well may not be fit for purpose. Again, this could be applied to any stage of handover information in the construction industry. The formats we tend to exchange in tend to be ones that we know other people can use. And I think the next one, yeah. And it's easiest to give them sort of the most common format. So you could export a construction drawing as a DWG or something that just describes geometry, lines, points, text, things like that. And they should be able to understand it, but it may not be useful for the tool that they're using. So you might use a different format, or they may request it in another format again. Ideally, you'd use an open source format. That would be fantastic because you could export your entire model to an openly accessible data standard, and somebody else will be able to interpret that on their end and use it straight away. However, a lot of times those exchange methods aren't implemented correctly in the tools that we use to design buildings. So in a little bit of experience I've had with exchanging between different proprietary softwares using open exchange formats, it depends on the writer or the creator of that proprietary software to implement the open source standard effectively. So that's the first stage of it. If they implement it correctly, then the information they've got in their proprietary format can be exchanged to that open source format, and it's ready to use again. However, a lot of times it misses the mark slightly. So in Revit, I know if you export a fairly complex building model to an IFC format, a lot of the elements within that model will just be exported to an IFC building element proxy, which is basically a placeholder for something. It doesn't quite know what that something is, but it has some attributes, and it is definitely something. It's not nothing. And at that point, well, what do you do at the other end? You've got a model which you've got some structure, you might have some windows, and you may have some mechanical equipment, but a lot of it is missing. If I was to bring that same IFC model into an energy analysis software, or move it from Revit to ArchiCAD, unless the mapping between the element you have in Revit to the IFC is correct, the other end of that process, you're not going to be able to read that same element. It's going to read it as an element proxy and say, well, I don't know what an element proxy is, so I'll just leave that aside and I'll just bring in the things I do understand. And then that's also assuming that the receiving modeling software actually has implemented the reading function of that open source correctly as well. So as well as exporting correctly, it needs to read it correctly. So there's quite a few little hurdles in using open exchange formats effectively, which is why you tend to get a few ad hoc methods developed for specific programs, which is why I'm an engineer, I think, technically, but a lot of my work is in interfacing with data in models. So if there is a specific thing you need from one model to another, it's probably easier to just write a little script and say, well, I want this particular bit of data, and I want it in this particular format so I can bring it into another bit of software. And that's what we're starting to see in information exchange. It's a slight changing of roles in some areas for people to be able to do this kind of thing, to handle data rather than models. And there are so many different ways of doing that, that it's slightly worrying that there's so many ways of doing that, because you're getting a lot of ad hoc methods. No standardization for export of information into other formats. So for instance, if I wanted to go from a Revit model to a open source energy modeling format, GBXML, I could write something in C# which would extract geometry, turn it into something which looks like a GBXML, and write it to an XML file. Or I could do it via a visual programming interface, Dynamo, plug into Revit, something like that, and then maybe use a bit of Python in there as well. Or I could go from Revit and I could go into another program, Rhino, and I could load up a plug into that called Grasshopper, and I could create something in Python or C# to do it. Or I could export it to a DXF, or I could bring that DXF into Rhino, or I could rebuild that geometry manually, or bring it back into Grasshopper. So the paths this information takes can be so circuitous that it's not really fair to expect it of the construction industry. If the tools that we have available to us aren't fit for purpose, then you're kind of forced down this route of making ad hoc methods of doing what you want to do. However, then you lose a lot of that standardization, and its applicability to multiple projects can then be compromised, and you may not be able to replicate it later on. The skills may be lost, the tools may be lost, there may be changes in versions of software. So yeah, lots of issues with information exchange. And I've kind of mentioned it a little bit already, skills gap. There is a big skills gap in the construction industry. Handling data is becoming the new, one of the new key skills to have. If you're interfacing with models, many of us are not computer scientists and don't know what tools are available to achieve certain things. But if you do know those tools and you have the time to be able to develop skills in them, then it opens up a whole world of possibilities of what we can actually achieve. The practitioners within industry, both designers and operators of buildings, they indicate a lack of confidence when handling data, because data is what we're not familiar with. We're not computer scientists or database admins. Interfacing with data is not in the usual repertoire of skills required for the day-to-day jobs, but it would be a great benefit to workflows, just having a basic understanding of the principles of data management. how lists are structured, how dictionaries can be created which map different properties to each other, how to access the data that you may just need for one particular job and no other jobs, but do it quickly rather than having to go through other existing processes, file sort of menus and plugins to programs which you don't really need a plugin if you can have a script to do it for you. So the image you can see on the screen there is from a little study of multidisciplinary engineering consultancy members, showing the level of confidence employees had in their abilities in and around BIM environments in particular, not sort of data management stuff, but just BIM environments. And there's a huge variability between different roles and different experiences and different disciplines. But underpinning all of this is the appreciation that the roles are going to change, that we are moving from engineering buildings to engineering data describing buildings. So yeah, it's an exciting time to be in the construction industry, definitely. The implementers of whatever you could call this data handling thing, a handover of a project to the building operator or the client, the facilities manager, the focus then moves to them, and they are going to manage the ongoing operation of a building, make sure it runs as well as it can and meets the expectations that they have. And they're responsible for, well, everything then. It's been handed over. Once it's past its defects period, they own the information, they own the building. And they may not have the task, they may not have the skills to be able to upkeep that information, upkeep the models, or implement any changes to digital representations of data based on changes in the actual building. So you end up with those information silos again. Another common problem in the construction industry, silos of information, which getting information from one to the other or accessing them can be a bit of a challenge. So they rely, at that point, you're kind of relying on the handover of conventional information rather than digital data, because conventional information is more easily used, more easily updated, because that's where people are more experienced. And there's nothing wrong with this, but viewed from the wider perspective of the built environment, moving towards that digital future for design and operation, it represents a significant obstacle to the utilization, maintenance, and accuracy of data describing buildings and data describing building performance. So this, what you see there, is what used to happen. That would be handover information. There's probably a bit too much handover information there for a building, but paper documents describing a building's performance. And that's what we do now. We do exactly the same. It's just files on a disk instead of paper. It's not structured. It doesn't have any kind of quick and easy way to find things unless you count searching within files or Control F. It's just unstructured data which may not be usable. And if we're building models, if we're creating BIM environments, then surely that's the next stage in handing over a model. But you need to make sure that model is accessible and usable by the building operators and facilities management to kind of make better use of it and start interfacing with it effectively. Consumers, I guess, will be the next step. They use the data. So you've handed it over, you've created it, and now it's being used. And they are going to be using whatever technologies or systems have been put in place for them. They don't create methods of doing it, they use. So facilities managers may be classed under this, as well as building owners and occupants, but they are all directly affected by the performance of a building they inhabit. The capability that is responsible for sort of managing that operation to interact with the data and make sense of it in kind of effective forms is limited by their existing skills and the tools they have available to them. So there needs to be tools that are there for them to be able to use this information effectively. And capabilities are lacking in this area as well. So any tool that's developed needs to have some kind of training to go along with it, or any tool that needs to be developed actually needs to be developed in the first place. I don't think there are many service offerings for building management systems where you grab all the census data in a building, put it into a nice interface, and make it viewable by the person that pays the bills for that building. Developing tools to interface with this kind of data is really challenging as well, because there, again, it's another area of very little in terms of standardization. You have methods of recording data, you have methods of storing data, and there's quite a few of those for BMS, for building management systems. But whether they're implemented correctly is another matter. And I've seen a few building management systems now where you try and get data from them, and it's very poorly implemented. So there's no directly applicable tool which would just go in, grab all the data, and present it to you and say, well, this is what's happening in your building, and this is what you should do to make it better. It needs a lot of time and effort to get one of those systems working, and I think in the real world that is something that hasn't been done just yet. It's been demonstrated in academia quite a lot. There's a few projects out there already which interface a building information model with BMSs or BMSs with machine learning, or figuring out how the building should perform with regards to how it actually is performing, and how to get past that and give that information to the people operating the building. But the majority of those projects, in fact, I dare say, I guess all of them have been within academic realms or implemented in a university where you've got access to the data with no barriers to that at all. So yeah, implementation in the real world where everything's different and everything changes, and potentially there is no kind of remit to do whatever you want with the data because it's research, is one of those challenges again. So yeah, kind of trying to present that data as something like that is one of those challenges. And last but not least, certainly not least, the key to getting skills into the industry is through education, is turning the designers, engineers, and consumers of today into users of digital data. We're kind of seeing graduates leaving university with skills in visual programming, so plugins to modeling tools, things like that. And programming in schools is now a thing. I mean, when I was at school, I think Microsoft Access was about the extent of anything even semi-related to programming. But now kids are learning how to script things and code things, which is fantastic, at least within the UK. I'm not sure how it works elsewhere in the world, but there seemed to be a bit of a lack of computational science or computer science implemented anywhere in the 90s. And the movement of some softwares in the construction industry is now allowing us to interface with them in different ways. So having the skills to be able to use those interfaces, access the APIs for certain programs, and change data or exchange data in new ways is brilliant. But we need those skills originally found in data science, in database management and programming, to be brought into engineering and construction and architecture. Because without those skills, we have a lot of data and no way of actually working with them. And we have a lot of data and no way of actually using it in any way to make buildings better, make them work better, make them perform better, make them use less energy, things like that. So there's definite need for upskilling of both the educators to be able to educate people how to do this, educate those going through construction courses, through facilities management courses, and upskilling of the workforce that's in place currently. And I know there's a few sort of endeavours at the moment. The IFMA and the IFM for facilities management are kind of pushing a little bit of this education currently, and the BRE in the UK have got, I think, a few courses should be starting at some point that sort of focus on upskilling for computer science related skills. Sadly, the documents shown in the images are quite dated there, and the development of these skills is taking time. It's going to take time because people are on projects, on real world jobs, and that takes away from sort of development time or being able to learn these new skills. But it will happen over time. It will happen. Maybe 10, 20 years. We are the construction industry after all. Things take a long time for anything to happen. So I think that's a broad overview of the subject, a few of the challenges we're currently facing. And this is what could be happening, what is the potential. So this is an exemplar project. This is a building I was working on during my research, during my PhD. For it there was no BIM model. It was built in 2013, so it was developed from 2008, meaning very early stages of BIM adoption in the UK. So very little uptake, and most information for this was developed using conventional methods. And the data describing the building was stored in the usual environments, in CAD formats, in Excel spreadsheets, a few PDFs here and there where people have decided to turn a Word document into one of those. And at stages of development, information is recreated manually, which meant the learning curve and experience of methods required to get the data into a state utilizable in some kind of data environment is rather steep learning curve, that one. But it was a good example because this is an exemplar of the construction industry as it was, or as it may currently be in some circles. At handover, the commissioning of this building took about 1 year, 1.5 years, and the BMS for this was okay. It monitored the building and it kept the plant operating, but it wasn't structured in the best possible way. So there were a few issues in how to access data that was relevant and correct, to say it shortly. But there was lots of it. There were 3,500 sensors monitoring in places every second. So there was gigabytes and gigabytes and gigabytes of data being generated. I'm currently going through it at the moment, and I think one backup of one of the sensors for the last year had something like 65 million rows. So there's lots and lots of numbers there that could be used for fantastic analysis or help understand the building in some ways. So during the development of the design information for this, I kind of looked at the process there and saw where is information coming from and going to. And if you map that to a BIM development framework, you could quite easily see what parts of that are relevant to building performance data and when that data needs to be made available. So in the end, at the end of that kind of circle you can see there, from concept design through to develop design, technical design, I think it's tender and construction. It's one that's highlighted with building performance information. That is where you kind of gather all that information together, and you should give it to the user of the building to say, this is how your building's performing. If you have the data there, you can compare it against this and potentially understand better how it's actually working, or use it to inform decisions. But I was mostly concerned with performance data being provided at the end of the design process. So this was kind of my method of getting my head around what performance data there was available. So as there were no models built, I created a representative model of the building using the existing documentation. Now, the process I'm describing here, it's very simplistic, but essentially these are the stages needed to get to a point where you've got a model which could interface with data and use that data effectively. I created a standard for this project by creating a model using the existing documentation, built to a standard where information is necessary for performance design and optimization. Within that model, there's MEP objects, there's plant equipment, things like that, and data describing that equipment that enables you to simulate it. And because it was modeled with this specific purpose in mind, for just building performance, it works okay. But that's just because there's one specific purpose, and it's easy to create a standard for one specific purpose. If you start to include structures or, I don't know, external infrastructure into that, there needs to be more scope for expanding that information structure. But it's a good example of an ad hoc one. So yeah, I can't remember where I was. Yes. In a conventional means of handover, the kind of data being generated, so performance data, is fairly big. But usually you can boil it down to the building should be kept at this temperature, and it should use, and the maximum power it should use is this, or the maximum amount of water it will be using is expected to be that. So using a bit of scripting, you could create a format which you could then interface with a BMS system. You could kind of link those two sets of data. So that's what I did here. I had a model with some data contained within it, giving kind of expected power loads or heating loads or CO2 set points for those spaces, and just created I think it was a JSON file format that you can see there, the text on the screen, representing those spaces, and that would enable me to link it to data describing those spaces that was being live monitored. The amount of data that could be connected, I mean, I had a simulation for a full year's worth of performance during design. Why not link a full year's worth of performance to the actual building performance and then compare each hour of the day to each hour of the year simulated? There is a challenge there in the amount of data that you can exchange between these methods. Initially, I tried to put all of that data into an IFC file because I had a nice building model, and you can put time series performance data into an IFC model. But if you were to do that, based on the number of sensors that I'd be kind of replicating, essentially, you'd end up with a huge file of around about sort of 16 gigabytes, which is way too big for an IFC. There's no way of reading that unless you've got some fantastic computer, which is awesome at reading big sort of open source construction formats. So that JSON was used as a method of getting that data across, fairly lightweight and easily accessible. Now, with all of that new data, and now I'm talking about the BMS data, the building management system, where it's kind of recording how the building's performing every hour of the day. There is lots of scope for error, huge amounts of scope for error, because it depends on how it's being implemented properly. And you can see in a couple of those charts, I mean the bottom two especially, the first one of those, it shows a measured data from, I don't know, space temperature or something. Measured power consumption in a space. And there's lots of values outside of what you would expect to be normal, and that's because the sensor was slightly broken. So if you've got thousands of sensors all recording slightly broken data, and you're performing automatic analysis on these, there needs to be some kind of sense checking, looking for gaps in the data, looking for insufficient detail, or automating some of the fault fixing. And while there are some methods of doing that, and I know there's a few articles out there which help get your head around kind of fault fixing automatically. If the data is not in the right kind of as you would expect, it's very difficult to use. So again, another one of those challenges to interfacing with data. If the data is wrong, then you can't really use it. Next stage, I had all this data. I wanted to link these two areas, and I've got my nice JSON format. So this is the workflow I followed. I simulated it, I created models, I turned it into an accessible format, and then I used Python to visualize it. And from that, you can start to see visualization of how the building is performing, and the client can see this and know where they're using power, where they're using, or where they're overheating, where spaces are being underconditioned, or just look at it as in a dashboard and quickly see, well, we're currently using way too much lighting, or way too much power for lighting. We don't want to be doing that. We could save a lot of money there. Or start to summarize the data. I mean, all this it's the same data, just visualized quickly and effectively using code, which most facilities managers may not have the ability to do, but the potential is there because the data is there. Start visualizing historical performance, looking for trends, or start aggregating data so you know load profiles. I mean, this here could be used for a future building project, where if you've aggregated sort of building load profiles for the last few years for lots of different types of buildings, you would know, or we would have a good idea. We could train an algorithm to tell you, I've got this type of building, and I want to know how much power it's going to be using during this time of the year, or how much energy it's going to be using for heating. And because a lot of buildings are now monitoring this data, and the data may be becoming available here and there in different areas, it's something that can be used to start doing more in-depth analysis and start looking at how that data can be used to inform design decisions or identify areas of performance deficiency. So this one here, this was using just space temperature data to figure out where spaces were performing or underperforming, or where they may need some more heating, or where they were losing some heat through thermal bridging, things like that. At the end of it, it was the evaluation of all of this and kind of summarizing all of the learning that was made. Is that the right term? Learning that was made? Learning that was done. So silos are still the main barrier to sort of exchanging data, as they always are. There's a huge disparity in the modeling during design, because modeling during design is done for specific purposes. So one model that describes a building may not be the same as another model, even though it describes the same building, because they were modeled for different purposes. The extensibility of a modeling format limits the amount that you can exchange that format, because there's more likelihood that some of the details within that hugely extensible format are going to be overlooked. The accessibility of data, if you're not connected with the right people, or the right data you need isn't being generated anywhere, then there's a barrier to how you can achieve what you want to achieve with that data. If you don't have the right software and the data is hidden in a format, you may not be able to access it. You can overcome this with a bit of skill if you know how to kind of bypass a few things, or just load the data and create a program which could interface with it. But most people aren't going to be able to do that or have the time to do it. Usable data is the most useful. If it has errors within it, it becomes much less usable, as I found out when I was trying to kind of see how a building was performing. If it's recorded in the wrong way, then you don't know how much energy it's actually using. There needs to be some kind of structure to it in some way that you can query the information effectively. How you structure data for databases is an entirely new subject to me, especially. But for time series building performance data is kind of a new-ish one, because the way you store information in a database can be done in several different ways to achieve the same goal, only the efficiency of that storage and accessing that data is something that needs to be considered for the purpose of storing it. The handover, or we're going handover, not handover. Existing technical capabilities of operators may not meet the requirements for interfacing with handed to them upon sort of construction, design, and building handover. And the roles that we all have need to adapt to make best use of the data being made available to us. CDEs are changing to suit database-style development environments. So in the company I'm in at the moment, we are starting to use, on some big projects, a database in which a lot of simulation data is sort of fed in and then can be extracted out for analysis purposes, rather than having all of that information stored somewhere else in proprietary formats. You put a quick script at the end of that simulation to just store it in that common format so that it can be used by other people in other ways. And these are what I think are the big challenges. I mean, they're a bit kind of high level and there's not much detail sort of given, but they cover what needs to be addressed. Is there a best format in which we can store performance data? There probably isn't. There's probably best or suitable for purpose formats, but it's tempting to try and aim for that best format. I know IFC is kind of aimed to be that de facto standard for open exchange format for building data. Should there be one for performance data, but I have a feeling it would just be developed and then sort of used in academic circles and then not used by industry, or just added to the list of existing standards available. What are the key metrics that we should be measuring in building performance to actually make sure we're using the building as best? And if we have those key metrics, exchange them with everybody so that we know how buildings are performing and we can compare them and identify where we're falling short of targets. And that's kind of essential to that comparability between building typologies. No two buildings are the same, but buildings can be defined in certain categories. You have a hospital building of a certain size. You may expect it to perform comparably with another hospital building of the same size. Again, there's going to be disparity between them, but having a huge set of data to draw from means you can start to understand that sector more and understand patterns of different performance. I don't know, there's I can't remember, one of the research labs in the US has created a fantastic explorer of data where you can look at building typologies and heating loads and cooling loads, and just filter by building type and types of services and types of plant and start to see those patterns, which is really, really interesting. We need to kind of quantify how we can manage data intelligently. Quantifying performance, it's quantifiable, but you can't control for every single factor. So I'm not sure where I was going with this particular grayed out text, but I think it was along the lines of, we have a lot of examples of niche, novel tools and capabilities in academic circles, in published papers, and they are fantastic. Some of the things we can do are brilliant, but they're not replicable in the real world because of the variability in that real world. The factors need to be accounted for. And finally, what aren't we doing that we should be, and what could we be doing better? Look at the things, the tools we're developing, or the processes we're using, or the ways we're exchanging data currently. I mean, we're using methods that have been defined, that have been used in the past, and we modify them to suit our needs. But is there any way we could use them better, or use them in some kind of way which would mean less work later down the line because we've used them in a slightly modified way? Or are we creating more work for ourselves later on in sort of creating our own little mini standards here, there, and everywhere? So yeah, the challenges. There's lots of them. I think I keep coming back to challenges. I think the outcome of my research was there are lots of challenges, but there is also a lot of potential with that. So I think that kind of brings me to a bit of an end. I know there haven't been any questions asked throughout. Well, there was one, but I hope I addressed that one, Asif. If you have any questions you want to ask now, or any topics you want to kind of raise, hopefully I can sort of discuss with a few of the panelists, please raise your hand or send a Q&A. I'll be happy to oblige. Yeah, I'm not sure everybody can see these, but I'll read out the question.
I can see.
Help them. You can see them?
No.
Ah, they can't. Okay, then I'll read this. This is a question from Peter Damien. You highlight the issue of standardization. Do you see any in the argument that standardization makes life easier for data users but can burden data creators? I'd say it limits data creators a lot more than not having them there, because you have to create it in a certain format. So it's going to be a burden definitely to them. It may also be a burden to data users, because they may not have the data that they want because that standard isn't available. So if you apply a standard to everything, you're going to limit what you can put in and what you can put out. So it's kind of a burden on both of them. And that, I think, is why the standards that we currently use may not be fit for purpose as they currently are, because they are standards that are meant for everybody. Yet they are also extensible, so that niche cases or fringe cases can be used or applied, and because of that, you tend to get the cases where you have the Revit model exported to IFC that doesn't quite import into another model because it's exported something a bit niche or a bit more. You've a strange roof design, which IFC isn't currently capable of handling. And Revit is very capable of handling it, but that standard isn't in IFC, so it tends to get lost in translation. Yeah, again, I hate these kind of these answers where you have to say, well, it's a bit of a balance, but it is a bit of a balance. And there needs to be standardization to the point that data is accessible, but not to the point that it's inextensible. I hope I answered that one. Does anybody else any of the other panelists want to kind of feed in or have any points of view on that?
Yeah, hi Tristan. I just wanted to ask you this question. You talked about the scale of information that is generated during the life cycle of a project. And you also talked about the kind of challenges that data would present. In this, you also talked, for the need for an effective management process or a standard for data management. So I'm just wondering, think information on our data management practices would change in the future?
So how would it change in the future in terms of the life cycle performance information?
Yes.
Okay. I think there's a bit of music playing somewhere.
Yes, whose music?
It's quite good, but oh, there we go. Cool.
Thank you.
So there are some kind of standards for life cycle building performance information available. There's I think Project Haystack and OBIX are sort of
all the music.
Or sort of coming to themselves a little bit more now.
Yeah, could we try and see where that's...
Where's the music come from? Or is that the WebEx? Please get off the system now. You finished. Music. I'll carry on. So yeah, the Project Haystack and OBIX are started to become available for kind of building performance data in use, but they're not really being implemented yet. The whole monitoring and managing performance data in a building's lifecycle is yet to kind of adopt a standard method of doing things, because the tools are available from proprietary software providers or providers of building management services to manage them. However, they may not be implemented in the right way for them to be kind of directly usable by the client or the operator. There may be a full functioning toolkit on an exemplar building that they have, but it's not implemented in every single building in the same way, or every building is slightly different, so some functionality is lost or broken. But those open standards would be a fantastic addition to that kind of data area. It's just waiting for them to actually be adopted in the real world outside of academia, which I think that does mean there will be some kind of proprietary, non-proprietary, some ad hoc standards created by people to manage their data for them, which is great, because it means the skills will be developed to handle that data by different service providers, by different facilities managers, by clients who own buildings and operate them. But again, it's more ad hoc standards and more opportunities for issue to happen when you try and aggregate data on a grand scale. I know in the UK, the government's starting to look towards the future of building data being aggregated, so that rather than monitoring a building's performance, you monitor a city's performance or a region's performance. And if everybody's using slightly different methods of structuring their data, it's going to be a hell of an undertaking to try and bring it all together. So yeah, there's opportunity there to kind of test and see which one of these new potential standards may be useful or how best to implement them. But I still think it's fairly undefined about what we should be doing with big data, lifetime performance data, which is going into those realms of big data of terabytes and petabytes of numbers.
Mm-hmm. I also had another one that I wanted to ask you about, which was about you talked about keeping data usable. And now with the scale of information that is being generated and being stored, how do you ensure that in the future you don't adopt a practice of storing everything, which is of little or no significance for the future?
Yeah.
And how do you only keep that which is of value? So what are your views on that?
Well, my personal views on keeping data are that everything should be kept, and storage is now cheap. You can store, I think there's a new terabyte micro SD card that's been developed. It's hugely expensive at the moment, but data storage is now cheap. However, I understand what you mean in that there can be too much of a good thing, and handling that amount of data can mean any changes you want to make or any kind of queries of it can take time, and it slows down the whole process, and most people don't want to store that much data. So in most cases there could be kind of a hierarchy of how much data you need for the type of building you are actually monitoring. So somewhere where you have sort of business critical operations like a data center, you want to monitor the temperature of those servers so that they don't overheat. You want to make sure your plant equipment is providing the amount of cooling to that server farm so that it doesn't overheat and businesses lose millions in revenue because nobody can access their online checkout. So in those kind of cases, you want to measure as much as you can. However, in a school building where you've got fairly predictable kind of schedules, people coming and going, fairly standard room uses, you might only want to know space temperature here and there. For key areas, you might want to know how much power is being used during a week, so you know where your demand is, and sub-meter it based on different departments, things like that. But you don't need to know every single little thing. So some sense has to be kind of used to make sure the right data is being recorded for the right purpose, which I think is why you'd need to kind of define the KPIs on kind of project outset. How much detail do we need to go in, and is this enough detail to get what we want from the building and understand it in order to manage it better? So yeah, it's definitely something to think about. And whether there is some kind of guidance anywhere, I'm not sure about that, but it'd be nice to think there was, or if anybody's listening and wants to create it, then please do. It would be very handy if you have a list of building typologies and the KPIs that you need to monitor to effectively manage that building, because I'd be really interested to see that list. There's a question from Atif here. Are there any classification systems like OmniClass and UniClass to help in data standardization? Data standardization is a bit of a misnomer, because is there any real way to standardize data? I mean, data can have structure. You can structure data, but if I have lots and lots of data on a server, it's up to whoever implemented that server to create some kind of structure and make it accessible and make it navigable. So in terms of building performance data, the two ways that I see that you could do it are storing object. So if you imagine you've got a value that's being recorded, that value represents an attribute, and that value has a timestamp associated with it. So a standard for that could be, well, I have an object and it has a timestamp, a value, and a name. And then I have another object that has a timestamp, a value, and a name. And my database just comprises of all of these objects. but that might not be efficient. You might have a better way of doing it, and you say, well, I've got a list of dates of timestamps, and I've got a list of objects, and I've got a list of values, and you can query that in any way you want and get the results you need. So I think in terms of how the data is stored, it could be sort of stored in some standard way, but as long as you can get it out in a standard way, it doesn't matter how it's stored. As long as there is some method of creating a view of that data so that it can be used in some kind of tool or application built for that specific view of the data, then fine. You can store it however which way you want. And yeah, I hope I've answered your question. I hope I haven't misinterpreted that. In terms of classification systems for data, that's another thing that the construction industry isn't really doing very well. Database administration needs knowledge of what format data is in and what kind of, when I say format of data, I mean sort of the data type. Is it an integer? Is it a string? Is it a float? Is it an int32 or an int64? How long is that number? What are the extents of that number? And currently they aren't being implemented very well in building management systems, which means if you want to get a load of data describing historical performance, you've got potentially bloated data where you may not have bloated data if you'd specified, well, that number is only going to be between 0 and 255, whereas the database expects it to be between -4 million and +4 million, which means it takes up more space on that database, which means that database is then huge, even though it doesn't contain that much data. It's just allocated that space for that particular data type. So there's a few issues in how the tools that are being implemented but not correctly in a way to make it accessible and usable. It's great for monitoring how a building is doing as it happens, because usually there's a dashboard for that, and you get the data from a sensor and it displays it on the screen. But if you want to look at historical performance, standardization of how data is stored and the types and formats of that data are stored would be fantastic, but it's something that I think is yet to be used properly, because we're in the construction industry, we're not in the computer science industry, and the people implementing these don't necessarily know. So yeah, hopefully I didn't go on too much of a rant there. I've had experiences with trying to get data from databases, and it's been painful. So do we have any more questions at all? Any more comments from any of the panelists?
If I could ask again, there's another one, which is you talked about the need for upskilling, and I know that through our several discussions over the last 4 years, we've discussed this endlessly. What do you think is the future expert? Because the way I see it is that the boundaries between disciplines, as we know them now, which are more silo-based, would be blurred. And it would create a new breed of what I would term as a cross-boundary expert. Do you agree? What are your views? And what do you see as the future in terms of skills? Would universities exist as they do now?
I think universities would continue to exist as they would now, only you end up with there's those that want to look. It's about any new technology. You get the early adopters and those that follow. I can't remember, is it the McLeamy adoption curve, something like that, I believe, where the early adopters go in there, they try out all the new things and they develop the new ways of working. At the moment, that's what we're seeing in the construction industry. It's kind of grassroots approach to developing these skills. So somebody that has an understanding of building engineering may start looking at a bit of programming and thinking, well, I can do this job much more efficiently if I program a few of these tools to kind of automate some of my workflow. So that, I think, is the first step. It will happen from within industry in terms of developing kind of like the grassroots capabilities currently, and universities are following suit in terms of kind of providing courses in tools like Grasshopper, which is a fantastic visual programming interface to Rhino, where you can actually write some code within it and see what's happening in nice, easy to use ways, rather than just looking at a big line of text on a screen, programming that way. But there's only a few courses doing that currently in the UK, at least, where it actually appreciates the need for upskilling of this kind. But they are very much within that kind of architectural engineering domain. So I don't think universities will change too much, but for the time being, you'll get this kind of grassroots level of understanding, and you'll end up with roles sort of sit between disciplines. We're already seeing it in Buro Happold at the moment, where you have computational engineers, where it's people that know their subject, but they also know a bit of programming. So they tend to be tasked with or enjoy creating these tools and capabilities to help us do our work more effectively. And until we start getting skills from those being educated in universities, in training courses, to come in and start to do this in their day-to-day jobs as an engineer, as a designer, you will have these kind of go-between roles of computational engineer to fill in that gap and talk to somebody that says, oh, I really want this particular functionality, could you develop it for me? And then we say, yes, of course, that will be 1 week, please. So yeah, I think that is the future of what is happening. Eventually, those skills will be coming through because there is going to be a greater level of understanding of the potential benefits of interfacing with data rather than just models in university, and that joining up with the skills that are being developed in industry currently.
Okay. I think that answers my question. Thank you.
Cool. Thank you. Okay, I think that might be everything I've got on my Q&A thing here. Have I missed anything? No. Cool. So if that is absolutely everything, I think that may be us finished. But thank you everybody to sort of joining and listening in. Hopefully you found it a bit informative. And I've had a chance to vent about the last 4 years of research. That's been quite cathartic, I think. And I've enjoyed answering your questions. If there's any other questions, I think if there is an email sent round sort of giving you a link to the YouTube video of the recording of this, hopefully I'll be able to get my email in that, or add a comment to the video itself if that's possible. I'm not sure if it is. I'll have to check with Michelle about that.
Yeah, well, I will send around the video, and if there are any questions, could send them to CIB, and we send it through, or directly to you. But we will arrange that. No problem.
Okay, that's fantastic. Right then. Well, once again, thank you very much.
Thank you, Tristan, for your webinar. It was very interesting, and hope everybody liked it. And we will let you know when it's available on our website and on YouTube.
Cool.
Thank you, and thank you, Michelle, for all your help with hosting this.
That's no problem.
Yes, thank you very much.
Nicely done. Thank all the attendees for your attending, and hope we'll meet again in another webinar from CIB. Have a great day, and we will close this webinar at this moment.
Cool.